Hello everyone. I welcome all of you in the next online class of dairy and food engineering subject. So in our previous units or in our previous classes we had our discussions on milk properties such as thermal properties of milk, chemical properties of milk, physical properties of milk. So this we all started in our first unit, and then followed by we discussed on dairy products, various numbers of dairy products such as paneer, chana, ice cream, butter, cheese. So this all we completed in our second unit, and later we followed some processing operations which we include in milk processing industries such as homogenization, milk sterilization, milk pasteurization. So this all we completed in our last lectures. So now today we'll be starting our next lecture or next class on dairy plant design and layout. Okay, next. Okay, so today we'll start our discussions on dairy plant design and layout. So if you want to start a new dairy plant, if you want to start off a new dairy plant, then the major things that we need during startup, that are mainly, is our basics also, that are mainly raw materials. Okay, but before you have the raw materials, first you have the idea, or first you should have the plan that on which product you are going to start the dairy plant. Okay, so first you collect or procure the raw materials, and then after having the raw materials, you must have proper unit operations or processing idea, or minute operations, that how you are going to produce the dairy, your product, or how you are going to uh, uh, so you must have the processing idea, that how do you use the product or your byproduct, and after having the processing idea, you must implement. Okay, and after implementing, you can start the production, and after production, then you can marketing and all, you can start. So before you have the raw materials, so as I said earlier, that you must have the plan of product. Okay, suppose you are producing one chana, or you are producing standardized milk. You are producing one standardized milk. That means the raw materials what you need, first you must first you must list out all these. Okay, so how do you produce the standardized milk? First we must discuss on it. Okay, so if you procure milk from farmers, if you procure milk from local farmers, then you can't say, or you can't predict that all the milk what we collect from the farmers will be having same percent of fat. Yes, because some cows or some buffaloes or some cattle, they give 4% fat in milk, some will give 3% fat in milk. So there must be the variation in milk fat. But if you purchase the milk from market, then you will find that there on the packet of milk pouch, it's written 4% fat in milk. So this must be done by the help of this standardization. So this is called as standardized milk. So this is the need of raw material, and then as a raw materials you might need water, you might need steam, you might need other fuels. Okay, you might need other coolant. So these all are the raw materials first you list out during this plan design, and then the processing idea So as I said, how do you produce the standardized milk? So first you must have the flow chart of it. Okay, first you must have the flow chart of it. Okay, so if you want to have this standardized milk, then how do you start? So first you procure milk. Okay, after procuring milk, you must store the milk for a long time, or for a certain time, because once you receive the milk, you are not going to start the processing, right? You store the milk in a somewhere, in some place that where the milk must not be spoiled. So milk must be stored in a storage tank. Now here what happens, as I already discussed, that during the storage of milk, there is a chance of creaming on the surface of milk. So this creaming of milk, it happens because the fat globules comes at the top surface of milk, because we know that the density of milk fat globules is very less compared to milk. So as density of fat globule is less, the fat becomes lighter compared to skim milk, and it comes on the top surface, so milk is spoiled. So to avoid this, we must do homogenization. Yes, we must do homogenizations, so that the fat globule size must be reduced, and as the fat globule size is reduced, then it can be stored for a long time. Okay, another one point you remember, the while storing the milk in storage tank, we must store it at 4 degrees Celsius. This is called as chilling of milk. Okay, this is called as chilling of milk. So why do I need this chilling of milk? Yes, because you have found, it's found that in a milk, freshly drawn cow milk, there is a several number of microorganisms present. Yes, there are several number of microorganisms present in the freshly drawn cow milk. So it's always advised that don't drink raw milk without processing. Okay, so first you store the raw milk at 4 degrees Celsius, because at very low temperature, the microorganisms which are present in raw milk, they are not able to survive. So we can kill, or we can inactivate the microorganisms present in milk, and we can store it in a storage tank. So after storing the milk in storage tank, we can go to the next processing operations to produce standardized milk. So you can filtrations, you can do this filtration, you can do this filtration, or it's also called as clarification. Okay, filtration or clarification. So what is the need of this filtration or clarification? Yes, because in a freshly drawn cow milk, you find some unwanted particles are present, some dust or some stones, some metals, heavy metals you find in the milk, which are not beneficial to, which are health hazard. So we must filter the milk, and we must remove all the unwanted materials from milk. So this is also called as filtration or clarifications. You can that filtration or clarifications you can do by the normal filtration, like micro filtration process. Yes, and after filtration or clarifications, we go towards this pasteurizations. Yes, we go towards pasteurization. Okay, now this pasteurizations, already we discussed that this pasteurization process, it can be occurred with the two process, that is LTLT process or HTST process. So LTLT process, I hope you remember the time and temperature combination, that is 63 degrees Celsius for 30 minutes, whereas in HTST process, that is high temperature and short time, which we do at 672 degrees Celsius for 15 seconds. So these pasteurizations must be done to kill the pathogenic microorganisms. And here you remember, in pasteurizations, the target microorganism name is Coxiella bruneti. Okay, remember this name, Coxiella bruneti. Okay, yes. So now what is the benefit, what is the identification of these target microorganisms? Yes, because during pasteurizations, as I said, the milk contains several number of microorganisms. So this Coxella brunetti has been found. It's the most heat resistant microorganism. Okay, it's the most heat resistant microorganism. So while we pasteurize the milk at a high temperature, maybe at 72 degrees Celsius for 15 seconds, or maybe at 63 degrees Celsius for 30 minutes, it's found that this Coxella brunetti, if it's killed, then the other microorganisms which are present in the milk, that also be killed at the same temperature. Yes, so this is the concept of target microorganism. That is because it's the most heat resistant microorganism. And after pasteurizations, you go towards this homogenization. You go towards this homogenization, and after homogenizations you can follow this standardization. Okay, standardization process. So this standardization process, it's done mainly by this Pearson square method. Pearson square method. Okay, now in this Pearson square method, we first we separate the milk into cream and skim milk, and after separating the milk into cream and skim milk, we suppose you have, I'll give you an example that you have, your milk has 4% fat. Okay, your milk has 4% fat. Now you want to market your milk with 6% fat. Now what I said that your cow milk, it has 4% fat, but you want to market this 4% fat milk into 6% fat. Now how do you do this? By adding some cream, because we know that the force of fat, it's nothing but cream, right? So if you add more cream in the skim milk, then you can produce 6% fat. So this method is nothing but called as Pearson square method. So here first you separate the milk into cream and skim milk. Yes, so in the 4% fat, suppose your milk has 100 liters. In the 100 liters you have produced, after separating the after separating it into a cream separator, you produced no just assume that 10 liters of cream and 90 liters of skim milk. So in a cream separator, you have separated this milk into 10 liters of cream and 90 liters of skim milk. Then this 10 liters of cream contains 4% fat. Now in Pearson square method, you must add this 10 liter of cream into 90 liter of skim milk in such a way that it produces 6% fat. Now as an example, I must say that you may add 8 liter of cream with 90 liters of skim milk, and then it produces 98 liter of milk, 98 liter of milk, but it won't have this 4% fat. Now it will be having 6% fat. So this is the method of Pearson square, and this concept is of standardization. So here I just gave you one idea that how the dairy plant must be designed. That first you must select your idea that on which plant you are going to start up your business. So first you must list out all the raw materials for the product, and then you must have the processing idea, that the flowchart of the product. Okay, so like milk, then storage tank, then filtration, clarification, then pasteurization, then homogenization, then standardization. This all you must have the processing flowchart, and after having the processing flowchart, you must implement. Okay, so you must implement means you need the equipments, you need the utensils. Yes, so you first need a storage tank, or you need a silo, and in filtration or clarification you need some filter cloth, or you need some microfiltrations to remove the unwanted materials. In pasteurization you need the plate heat exchanger, you need means you need some heat exchanger which pasteurize the milk, and in homogenizations you need homogenizer. So with this all you need to implement the dairy plant, and after that you can start the productions, and once the production starts, then you can go for the marketing. So this is the idea behind this dairy plant design and layout. So once I finish all these discussions, I'll draw one general dairy plant design layout. I'll just give you the one flowchart of this as a block diagram. I'll give you the general plant design and layout, and later we'll start we'll just see that what are the different types of layouts are there in the food industry. Okay, मैं छोड़ दूं. So now we'll have the plant design layout. Okay, so this is the whole layout of this plant. So here first you must have the raw materials. Okay, and once you have the raw materials, you must have other accessories such as boilers, or you must have the refrigeration unit. So these are the raw materials, or other accessories you must have. And then you must have the primary processing. You must have the primary processing. And once you complete the primary processing, then you can look forward for towards this secondary processing also. Secondary processing. Okay, and once you finish the secondary processing, then you can go towards this production unit. You can go towards the production unit, and then you can go towards this loading and unloading of materials. Okay, loading and unloading of materials. And here you must have the quality control lab. Here you must have the quality control lab. Okay, or for testing the materials, you must have the analysis lab, or testing lab. And here you must have the toilets and washrooms you can have. Okay, toilets and washrooms. And this is the parking area. You can keep the parking area. Okay, so, and here you can remove the product unit. So this is basic idea of this general processing plant. General processing plant layout. Okay, so first you have the raw materials, then you have the boilers, refrigeration unit, then you start primary processing, then you have secondary processing. You must have the quality control lab, and then you can produce the product or dairy products, whatever you want. And after producing the product, and after testing the materials in a quality control lab, you can finally follow this unloading and loading, and then you can have this product in the market. Okay, so this is the idea of general processing plant. Okay, आपका पेन ड्राइव है मैम? So now we'll see some types of layout in the dairy plant or in a food processing plant. We'll see some types of layout. Okay, types of layout. So in the types of layout, there are 4 types of layout you must have, or you can see. One is called as product layout. Okay, one is called as processing layout. Another one is called as functional layout, and last is called as combined layout. So in food processing plant, there is mainly 4 types of layout, which are product layout, processing layout, functional layout, and combined layout. So the term is product layout. Here I'll give you an example that you have seen the rice milling, right? You have seen the rice milling flowchart. So how do you have the flowchart of the rice milling? So first, if you see the rice milling flowchart very carefully, you'll find that the flowchart is given based on the sequence of operation. Yes, based on sequence of operation. based on sequence of operation, the layout of rice milling is given. Like first you collect the paddy from, harvest the paddy from field, and after harvesting the paddy from field you do the cleaning process, and after cleaning the paddy you do the parboiling process, and after parboiling you go towards milling of paddy, that is in rice, I mean in rice milling. That equipment name is huller, okay. And after milling you go towards the polishing and then coloring, and this is all. So this based on the sequence of operations, if you have the layout, then this layout is called as product layout. And if you have the layout that is based on the equipments, okay, based on sequence of equipments, okay, based on sequence of not operation, based on sequence of equipment, then it's called as process layout. And functional layout, here you see that all the materials must be taken, or all the materials must be taken into one place, then it's called as functional layout, okay. All the raw materials must come at one place, okay, at one place. I think you have seen that how a house is built, okay, how a house is built, or how a infrastructure is built. Like first you have this sand, cement, stones, everything at a one place, and then you can have the product. So this is also an example of the functional layout. And last is a combined layout. So here you have seen that in all this product processing, or functional layout, you might have some disadvantages. Yes, you might face some disadvantages based on sequence of operation, or based on sequence of equipment, or this functional layout you can have you might have faced some disadvantages. So in combined layout, this is any two combined, okay. So this is an example of this combined layout. An example of soap industry is an example of this combined layout. So this is the types of layouts that are product layout, processing layout, functional layout, and combined layout. And last but not the least, you have some flow pattern also. You have some flow pattern in food processing layout, that are called as I flow pattern, that are called as L flow pattern. Another one is O flow pattern. Another one is called as S flow pattern. So these are some flow patterns we have in our processing layout. In I flow pattern, so this is my layout where this is called as inflow, and where this is called as outflow. So this is the example of I flow pattern. In L flow pattern, this is the layout you have, and here this is my inflow, and this is my outflow. So this is the example of L flow pattern in layout. Then you have this O flow pattern. Here you have this inflow here, and at the same place you can have the outflow also. So this is the example of O flow pattern. And last but not the least, that is S flow pattern. So this is my layout, and here, so this is the inflow, and this is my outflow. So these are some flow patterns we have in our industries layout, okay. So this is all about the plant design and layout. So today we have seen that this to design a plant, the basic need, what we need, the basic needs or the necessaries, and the types of layouts, and types of flow patterns. So this all we discussed in our class, okay. So as I said, to operate a dairy plant or to operate any food processing plant, we must have the raw materials, as well as we must have some other accessories also. We must have other accessories also. So these are nothing but refrigeration unit. Okay, these are nothing but boiler unit. So this all we will study today, electrical. Okay, so this all we'll see, just basic we'll see. So in refrigeration unit, you have seen that the purpose of refrigeration is to cool. The purpose of refrigeration unit is nothing but to cool the product below the environmental temperature, okay, at the storage temperature. So in refrigeration unit, you have seen that there are four components. One is called as evaporator, the second component is called as compressor, the third component is called as condenser, and the last equipment that is called as expansion device. So these are the four components are available in refrigeration unit. So in refrigeration unit, there is two section. One is called as low temperature and low pressure section, and another one is called as high temperature and high pressure section. So here in evaporator, a low temperature and low pressure liquid refrigerant, okay, liquid refrigerant comes to the evaporator, and this low temperature low pressure liquid refrigerant evaporates to low temperature and low pressure vapor refrigerant. Now here you see the refrigerant phase has been changed from liquid to vapor. So as it changes its phase from liquid to vapor refrigerant, it collects some latent heat from the product. It collects some latent heat from the product. So that is called the heat of refrigeration, or that is called as refrigeration capacity, or that is called as refrigeration capacity. And now this low temperature low pressure vapor refrigerant comes to the compressor, where it increases to high temperature and high pressure vapor refrigerant. Okay, so here the temperature and the pressure of refrigerant is increased to a temperature and pressure where it is called as superheated vapor. Okay, where it's called as superheated vapor refrigerant. So here it's done by mainly mechanical compression. Here it's done by mechanical compression, and then this high temperature high pressure vapor refrigerant comes to the condenser, where it condensed to the high temperature and high pressure liquid refrigerant. So again here also you find that the vapor refrigerant, it's condensed into liquid refrigerant. That means here also the phase change of refrigerant takes place. So due to the phase change of the refrigerant, here we need to supply some cold water. Here you need to supply some cold water, which changes the phase of refrigerant from vapor to liquid, and then this high temperature high pressure liquid refrigerant comes to the expansion device, where the temperature and pressure of the liquid refrigerant, again it drops to this low temperature low pressure liquid refrigerant, and like this the cycle is continued. So this is called as the refrigeration unit or refrigeration cycle. And you remember this refrigeration cycle, it's mainly followed by reverse Carnot cycle. Okay, reverse Carnot cycle. Why reverse Carnot cycle? I mean, there is I'll just tell you one name, because in Carnot cycle you have seen, in all the law of thermodynamics you have seen that heat always flows from high temperature to low temperature. Yes, because if you have any source of heat, and then if you have any system, maybe a heat engine, and if you have a sink where the heat has been lost. So if you see this, the heat transfer happens from the source to sink, that means T1 to T2, and where T1 is more than T2, and here the heat engine will do some work done. Heat engine will do some work done. That means work done is done by the heat engine or by the system. So this is the example of the Carnot cycle. Whereas in reverse Carnot cycle, if you want to cool the system, in that case, if you have a refrigeration system and if you have the sink, so in that case T1 is more than T2. Now in this case, if you want to supply the heat from this T2 to T1, means in reverse directions, then you must do work done, on the system. So here in reverse Carnot cycle, work done is done on the system, whereas in Carnot cycle, work done is done by the system. So this is a difference between the reverse Carnot cycle. I mean, this all we don't need in this class, but just remember. Okay, so this is all about the refrigeration unit. So here you have four components: evaporator, condenser, expansion device, and the refrigerant, the cools the product from high temperature to low temperature, the temperature where we need to store the product. And there are a number of refrigerant like ammonia, water, and there are a number of refrigerants, you remember. Okay, so and this Q is called as refrigeration capacity, and this refrigeration capacity is nothing but the amount of energy absorbed by the refrigerant to change its phase from liquid to vapor refrigerant. So that is called as refrigeration capacity, and it depends on the refrigeration capacity. You can produce or you can reduce the temperature from to a far extent. Suppose if you purchase, if you have a apple at normal harvesting temperature like 30 degrees Celsius, and if you want to store this 30 degrees Celsius apple at 2 degrees Celsius temperature at the storage unit, so then you must reduce the temperature from 30 to 2 degrees Celsius by the use of this refrigeration unit, and this difference in heat will be called as the refrigeration capacity. So if you want to reduce more temperature, the amount of refrigeration capacity will be more, and if you want to reduce the temperature up to a low limit, then your refrigeration capacity will be low, like that. And the mechanical compressions, the amount of work done by the on the system is called as this work done or the power unit. And remember this COP, that is called as coefficient of performance. This is nothing but called as Q by W. That is nothing but the ratio between refrigeration capacity to the work done of the system, that is called as coefficient of performance. Another one way it is also called as, suppose this is low temperature, low pressure is at T1, and high temperature, high pressure is present at T2 temperature. So T1 by T2 minus T1, it's also called as coefficient of performance, where all the values are in Kelvin, okay, or absolute temperature. So this is all about refrigeration units. Similarly, boilers also, the need of boiler is nothing but to heat the water or to produce steam, and to produce steam we must heat the water, and to heat any water we must need some fuels. So in examples of fuels, we may use some rice husk, or we may use some wastage material. So these are the fuels generally we use as a solid fuel, and as a liquid fuels you can have this other materials, gases also we use as a fuel. So you can use some byproduct or wastage as a fuel in the boilers. And you remember that the boilers, there are several types of boilers, like fire tube boilers and water tube boilers. So these fire tube and water tube boilers are classified depending on the tube of the boiler. Like in fire tube boiler, I'll just so here if you have the fire tube boilers, there are different layers. There are different layers in the fire tube boiler. So inside of the fire tube boilers, the flue gas is combusted. But in water tube boiler, so this is a fire tube boiler example, but in water tube boiler, outside of the boiler flue gas has burned, and inside of boiler steam has been produced. But in fire tube boiler, outside of the fire tube, steam has been generated. So this is the difference between fire tube and water tube boiler. Then there is depending on the combustion also, there is internally heated and externally heated boiler. So there are several classifications of boiler, and you remember one example of fire tube boiler, that is Lancashire boiler. And one example of this water tube boiler is Babcock and Wilcox boiler. So this all you remember as a notes on accessory of the plant. I mean, so, any food processing plant. So in a food processing plant, we must have a refrigeration unit and we must have a boiler unit. Okay. Okay. मैम थैंक यू चला दो एक बार. So today I'd like to finish my online class here. So today we have discussed on dairy plant design, the flow charts of dairy plant and general layouts, the different types of layouts such as product layout, process layout, functional layout and combined layout. And then we have discussed the flow patterns in the layout like I flow pattern, L flow pattern, O flow pattern. And later we have discussed different accessories of any food processing plant such as refrigeration unit, electrical units and boiler units. Okay. Okay, thank you.